Who is there online? Hi, Kaushik.
Hi, sir.
So we see the chapter 11, yeah? Human eye, the colorful world. So we are seeing chapter 11, yeah? The human eye and the colorful world. What do you say about, what do you know about eye? What are the different parts of the eye? Optic now, retina, cornea, pupil, iris,
Yes.
blind spot. So what else? Crystalline lens. Yeah. The aqueous humor. Sorry. Ciliary muscles. Right. So this eye is like a camera, right? So which is equivalent to. So what are the different parts of the camera? Sorry. What are there in camera? Lens. Good. Venkat? Lens. What else will be there in the camera? Lens, and there is a sensor. Sensor means so we call it pixels, no? That each pixel is a LED. It's not LED, it's a photodiode. Photodiode means what it will do? It will take photons and it will convert into current, current or voltage. So this light signal will be converted into electrical signal. So what happens with LED? Light emitting diode means electrical signal will be converted into light signal. So these two are two different. There is something called LED, which is light emitting diode. Means when we give input as electricity, input as current or voltage, it will convert into current. It will convert into light. That's why we call it as light emitting diode. So when it comes to photodiode, so it will take the when we it will observe the photons. What are the photons? Photons means light travels in terms of photon particles. So light has two properties. One is a particle nature, other is a wave nature. Light has dual nature, duality. So means it has a particle nature also, it has a wave nature also. So light travels in terms of light travels as a straight line, right? So it travels through the particles. Those are called photons. So light is measured in terms of this photons. Okay. So if there is a high intensity means there are higher number of photons. Let's say if I capture using camera, so the picture of this room I have taken. So where it will be the high intensity, which part of the, so in this different objects are there right here. So which will be of a high intensity, means which is bright. So here there is a bulb, light source is there, yeah, and wall is there and fans are there. So in this which will be the bright source? Light, yeah. So means there are it is emitting higher number of photons. So this number of photons and this brightness, they are directly proportional. Okay, so if some source is emitting higher number of photons means its a source is brighter, that object is brighter. Let's say when you take a sun, so when you take a sun in the morning, the intensity is medium or something, but when you take in the afternoon time, it is peak. So and then it will like it's like a goes like this, right? So morning it will be less and then increase. Afternoon very peak, and then it will slowly go down. So in the afternoon time, it will emit higher number of photons. That's why it's very bright. Okay. So yeah, these photodiodes. So every pixel is one photodiode. So it will take the photons and it will convert into electrical signal. So that will be converted as intensity. So that will finally give the color. So yeah, so here, so that is called sensor, where these photodiodes are arranged in a grid. That is called sensor. Let's say when you take a camera, so it's a which lens? Convex lens. Convex lens is which lens? Converging lens. Concave lens is called diverging lens. So let's say what is this one? This is called aperture. Okay, this is aperture, and there is a sensor. Okay, generally sensor we place at where we place it? The focal length. Sensor will be at the distance of f from the lens. So how to measure the focal length of the lens? Venkat? F equal to r by 2. Yeah. So the lens is given. So how can we say the focal length of the lens? Based on the radius of curvature of the lens. So if the radius of curvature is more, then focal length is more. F equal to r by 2, right? So if radius of curvature is less, then F will be less. So if I take a lens, this one, okay, and this one. Hari, what are you doing, Hari? Huh? Not able to concentrate? I will ask some questions. So there are two lenses here, right? So lens A, this is lens B. So which has higher focal length? Lens B. Why? Sorry? Say it now. Radius of curvature of the lens is? What's the distance? Not a distance, it's a radius of curvature. So the radius of curvature of lens B is more or less compared to A. Venkat? More, right? So that means focal length is also more. F equal to r by 2. So means if you want to measure out the focal length, so this is the lens, right? So if you need to construct the whole circle. Okay. And what is the here will be the middle point, right? So this will be what? The radius of curvature r, yeah. Okay. So F will be r by 2. But if you need to construct for this one, it's bigger, right? Bigger or not? So this will be R now. So F is directly proportional to R. F equal to R by 2. So let's say if we keep the object here. So this is the object. So what will happen? So let's say the rays are coming from infinity, where they will converge. So if the object is at infinity, then the rays will converge at F. Right? So what will happen to this ray? Sorry? Diverge means it won't pass through because so there is no path to go inside, right? So this will retrace back. It will come back as in the same route. Yeah, reflect. Yeah. So now if I take a lens with a so consider this one. Now this one. So here now if you take a eye, so what are the analogies here? Which will be equal to the lens, which will be equal to the, this is called sensor, where we see the object. Okay. So this vertical, because actually I need to show it in a 3D, but I'm just showing it in a 2D. Sensor will be in which shape? Sensor. Sorry? Sensor will be in which shape? 2D. Which shape? Rectangle. Camera sensor. Rectangle, right? So generally, how will you say the camera? You say camera megapixels, right? So you say 10 megapixels, or you say like 1024 cross 768, something like that. You will say, no? Do you know anything about this? Don't know anything about this? So when you take a camera, so finally we capture the image, right? So let's say this is the image. So it will be divided into pixels. Okay, it will be divided into pixels. So let's say if I say 1024 cross 768 means there's 1024 columns, 768 rows. So here, how many there? Can you count? How many are here? How many rows? How many rows are here? How many columns are here? Eight columns. 8 columns, 8 rows, right? 7 rows. How many columns? 8 columns. So we say that here 8 cross 7. So if you want to say it's a megapixels or something, you need to multiply both of them. Means 8 into 6 is how much? 8 into 7 is how much? So how much? 56. So it's a total 56 pixels. It has total 56 pixels. Let's say if I have 1000 cross 1000 sensor, total how many pixels are there? Sorry, that is 1 lakh or 10 lakh? 10 lakh means that is 1 megapixel. Mega is 10 power 6, right? Mega means 10 power 6. So there will be 1 megapixel. So that will be called as 1 megapixel camera. Okay. So that's how we say it's a megapixel or 10 megapixel or 5 megapixel means the total number of pixels which are there in the camera. Okay. So that is called sensor, camera sensor. So if number of pixels are more, then the picture quality will be higher. If number of pixels are less, then picture quality will be lower. So here, so all the light is being recorded on the sensor, right? The camera, the light will pass through the lens, and finally it will be recorded on the sensor in camera. So what about the eye? So what will be compared with the lens in the eye? Nana, retina is a sensor. All the light is being captured on the collected on the retina. Finally, so this is the red eye, this is the eye, right? Hari, you did not bring your textbook. Why? Tomorrow bring math book, okay? So tomorrow bring the scale and the protector, both of them, okay? So yeah, so here you can see now different parts of the eye. So first part is the cornea, right? Cornea, and then iris. So iris will be equivalent to what? Iris will be equivalent to okay. Which is the lens here? Lens in the eye. Crystalline lens, right? So lens is crystalline lens. So lens equivalent part in the eye is crystalline lens. So sensor equivalent part in the eye is retina, right? Where the total light is being recorded. So when the light is coming through the eye, it will enter. First it will enter through the cornea, right? And iris. Iris, it says about the aperture. Iris says about the aperture. If iris is it's closed more, means the less light will pass through. If iris is open more, then the more light will pass through. So opening is called pupil. Opening is called pupil. Okay, pupil. So if the iris is open more, then what will happen? The more light will pass through. What Venkat? It's not about that. So the more light will pass through. Yeah. If iris is open more means the more light will pass through. So if the iris is closed, very much closed means the less light will pass through. Okay. So let's say take analogy like a water in a pipe. So if the pipe width is more, then what will happen? The more water will pass through, right? The pipe width is less means less water will pass through. So this iris, according to also this ciliary muscles are there, no? Ciliary muscles will control this iris, so whether to expand or whether to contract. Good, yeah. So this ciliary muscles will do that action. So let's say if I am seeing the bright light source, then already a lot of light is coming out. So then the iris will contract. So let's say if I switch off all the lights, then this will be totally dark, no? Then this iris will expand. Then the more light will go. Okay. So this will be controlled through ciliary muscles. Ciliary muscles does this action. So and so finally this light will enter through. So in the eye we have the black part, right? One is black. So around that, yeah, white part, yeah, and so only the light will pass through only the black part. Okay, light will pass through only the black part. So we can say that is nothing but the iris. The remaining part is nothing but the iris. Okay, so only the light will pass through the black part. So not actually, so actually in this so here you can see the eyes, right? So yeah, So in that dark region itself, there is a black area and also there is a different area. The total is not black. So we have that like dark area, right, in the eye. That's not totally black. There is something black and also around that there is a different color. Okay, only through the black region only the light will pass. So the remaining part is iris. Yeah. So the ciliary muscles will control the contraction or whether to expand or contract. It will be controlled through the ciliary muscles. So what about this? What is the function of this optic now? Transfer the information which is received on the retina. Yeah, through the brain, to the brain. Yeah, then the brain will analyze it and then form the image. Okay. So first the light will enter through the cornea and it will go through the pupil. Yeah, and so there is something called aqueous humor. Aqueous humor means it's like a water. It's mostly water. And also behind the lens, what is there something called that's called virtuous humor. There is aqueous humor. Back to that virtuous humor. So it's like a gel-like, jelly-like substance. Yeah. So and then yeah, it's like a very transparent. Okay, transparent and jelly-like, and the light will pass through that, and then it will hit the retina. So which is the blind spot? Where this optic nerve is touching the retina, that's called blind spot. Where the optic nerve is touching the retina, that's called blind spot. So also how this light is, so there is something called on the retina, there's something called rods and cones. So these are the sensory elements which will detect the light. It's called rods and cones. Okay. So yeah, so now what is equivalent to sensor here in the eye? Equivalent to sensor is eye, retina, and equivalent to the lens is crystalline lens. Also, so at the cornea also refraction will happen. At the cornea also refraction will happen. After that there is a water body, which is aqueous humor. There also refraction will happen. And again at the crystalline lens, that also refraction will happen. So basically these three together will be act as a lens. Okay, so this is a compound lens. Compound lens means there are many lenses which are in contact together will form a compound lens. Okay, so but the final light control will be done through the iris, and which is finally through the ciliary muscles. Okay, so light will enter through the pupil. And then so this information will be transferred to the optic nerve. Yeah, so this light it will be converted into the, so to the optic nerves this information will be transferred, and then finally the image will be formed. So also we have two eyes, right? What is the reason that we have two eyes? Reason in the sense like what is the use of, like, let's say if I have only one eye, what's the difference? If I have two eyes versus one eye, what's the difference? Yeah, one thing is it will increase the visibility, not eyesight, it's a visibility range. Yeah, one thing is it's a visibility range, so that's not the main purpose. Okay, but what is the other main purpose? What can you think of? Hurry. Otherwise, why we have the 2 years? If I close also, I can hear, no? One ear also, if I close also, I can hear. Huh? Safety for? That's why 2 ears are there. Any idea? Why two eyes and why 2 ears? Venkat? So there is something called binocular vision. Binocular vision means, let's say I am seeing Hari, then I have 2 eyes. So the same image is going through left eye also. The same is image is going through right eye also, right? But they are separated by some distance, right? So there is a one image in the left eye, one more image on the right eye, but they're not exactly same. Are they exactly same? No, right? They are. So in the left eye, it will cover more information from the left. Right eye will cover the more information from the right. But both of the eyes have some common area, right? Both of the eyes have some common area, right? In the actually this common area, so what will happen is there is something called so take this is left eye, okay? I means finally the image. The right eye is this one. Let's say take this is the object, okay? So this will come here, this will come here. When I image it, when I see from the left eye, this will be here. The distance is this one. If I see from the right eye, the distance is this one. Okay. Now, if I move it little bit, then what will happen? It will come here. This will come here. Okay. So now take one more point here. One more point here. The same distance. Okay. So now what will happen? Actually, should. So there is something called shift. Huh? So here we can say that this is a distance x. Let's say this is the distance y. So x is not equal to y, no? X is not equal to y. So this is shift. Because of this shift, we can perceive the 3D. We can perceive the how far that person is. Okay, because of this shift, we can perceive the 3D. So if the person is very near, then the shift is more. And the person is very far, shift is less. Okay, so that's how our brain it has that information. From that information, it will say whether the person is near or whether the person is far. So it's called binocular vision. Also, what about with the ears is that let's say if something is if someone did the sound from this side, then the waves will move right towards my eye, right? So one wave will reach fast, so to the right will take more time. So there is a difference in the time. So that because by that difference we can say that this wave is coming from which direction. If it's coming by this direction means so it will reach this eye first. It will reach the eye later. If it is coming from this direction means it will reach this eye first, this ear first, and then later. So from that we can say that our mind can sense. So even if you close also, you can say whether sound is from this direction or this direction or this direction or this. So that is the basic use of this, having these 2 ears. You can localize the sound. So here eyes also to localize the person where he is, how far the person is. Okay, these are the huh? We started 5 minutes, 10 minutes late, na? Venkat, we started 10 minutes late, right? Today? It's 40 we started. So then we need to add 5 more minutes before. Anyway, you take rest, they will listen. No? Okay? Can you so did you understand about this one? Little bit? Little bit? Venkat? The sound one is clear, no? If means it will reach this eye first, it will reach the iris later. So based on this difference, you can say that how far the object is, and from which ear we are getting, that tells the location. Means which side it is coming. Direction. Direction is coming from. Direction is coming from. So if it reaches first and later means, so this is from this side, and the actual distance is coming from the delay in the. So let's say if these are ears, right? So let's say if this is the, here there is a sound. Sound wave is propagating and reaching here. Okay. So and it's propagating and reaching here. So it will reach in time t1. It will reach in time t2. What's the velocity of the sound? Is it 330 meter per second or something? Is that right? Velocity of the sound in the air is, I think, 330 meter per second. So if I know the time t2, how can I calculate the distance? Distance equal to velocity into time, 330 into t2. So what about this one? Let's say it's D1, D2. D2 equal to 330 into D2, D1 equal to 330 into D2 minus D1 equal to 330 into T2 minus T1. Math paper tomorrow. You had exam? You had exam in here or the school? Oh, when? Who was exam? Who was exam? Easy only? Math and physics, huh? Both, huh? Math was tough, huh? So let's say, Venkat, so if the T1 minus T2 is more means T1 minus T2 is more means when will be T1 minus T2 will be high? Let's say if I am here, okay, if the something sound is coming from here, when D1 equal to D2, what will happen? T1 will be equal to T2. Huh? Or DL DR. Take it as DL DR. DL means distance to the left ear. DR means distance to the right ear. So if DL equal to DR means TL equal to TR. Is that right? Good. It's exactly on this. Exactly on this line. It's exactly this, right. Yeah. So if it is like a means, so it will take the same path, huh? So it's I'm not good at drawing figures. Okay, don't worry. So exactly on this means exactly perpendicular to the my both of the eyes means middle to, then the distance to the left will be equal to distance to the right, right? Then the T1 will be equal to T2. Huh? So T1 will be equal to T2. Means yeah. So you can hear always both sides, but the wave will reach the both ears at the same time. The wave will reach the both ears at the same time. So if let's say T1 TL greater than TR means DL will be equal DL means greater than DR. Then you can say that it's the left side. No, you can say that it's the right side. If it's right side, then only DL will be greater than DR. If it's the left side, then DR will be greater than DL. So using that information, our ear can sense it. Which direction, how far it is. Okay. But there will be some ambiguity, but still we have some information. So on retina, there will be something called light sensitive cells, which are rods and cones. Light sensitive cells, which are rods and cones. Hold on. So eyeball will be approximately spherical in shape with a diameter of 2.3 centimeters. Eyeball will be approximately spherical with a diameter of 2.3. So the most of the refraction will happen at the cornea, and the crystalline lens will do a finer adjustment of the refraction. So when it contracts, it can contract also, it can expand also. So then the focal length will change, but there won't be so drastic change. It is a finer adjustment. Okay. You're not shaking your eye, you're shaking the head. So the people regulates the control of the amount of light. See, pupil is open more means the more light will enter. Pupil is open less means the less light will enter. On the retina, there will be this light sensitive cells, which are rods or cones. There is something called power of accommodation. Accommodation means power of accommodation means. So what is the power of lens? Power of lens is 1 by f. So what about the power of accommodation of the eye means? So we have eye lens, no, which is a crystalline lens. It is I think lens is adjusted by the ciliary muscles. Lens is adjusted by the ciliary muscles. Lens, not the iris. So eye lens is composed of fibrous jelly-like material. Its curvature can be modified to some extent by the ciliary muscles. Ciliary muscles will adjust the eye lens. Okay. So the change in the curvature of the eye lens will change the focal length of the eye lens. When the muscles are relaxed, the lens become thin. Thus the focal length increases. Thin means focal length will increase, right? So here also we can see, you know. So more thin means it's like a plane means it's a more focal length is infinity. For the plane has a focal length, planar lens has focal length is how much? Infinity. That is a more thin. If it is more thin means focal length is more. Yeah. Then this enables us to see distant objects clearly. Distant objects clearly. Okay. When you are looking at the objects closer to the eye, the ciliary muscles will contract. So when we look at the very near, then the ciliary muscles will contract and the lens will bulge. Bulge means it will, thicker. It will become thicker. Then the focal length will reduce. Right. We can see the near objects. If we want to see the far object, then the ciliary muscles will, and contract, and it will make the lens to be thin. Yeah. Then we can see the objects which are very far. So that's called accommodation of the power of accommodation. So means how much you can, what is the range you can see? That's the power of accommodation. So generally we can see the very near is 25 centimeter. Very near is 25 centimeter. But if you keep it very near, it will be like a totally blurred. You can't see it. No, there is some range you can see it. Right? But that's called, that is a generally 25 centimeter. Also, people will say, no, don't read books very close. No? then ice won't be able to accommodate it. Strain, very good. Yeah, ice will strain. But if we keep it at the proper distance, then we can read for a longer time. They won't strain. So the minimum distance at which objects can be seen most distinctly without strain, it is called least distance of distinct vision. It's called least distance of a distinct vision. It is called near point of the eye. Near is called near point of the. What is the near point? Huh? Yeah. So what is the definition of the near point? The minimum distance eyes can see without straining. The minimum distance is the object without straining. That's called near point. So what will be other point? Farthest point. It's also called farthest point, which will be generally infinity. Okay, infinity means exactly we don't see it, but generally say it infinity. Near point is 25 centimeter. Farthest point is infinity. Yeah, that's called the range of accommodation. Range of accommodation. That's the range. Yeah. So also when people are getting old, yeah. So what will happen to crystalline lenses? It will become milky. It's called cataract. And what must be done? Cataract surgery to remove that cataract. Then people can see it again properly. Right? Cataract surgery. So there is something called, do you know something is there? No, you can read both of them. So they're asking, why do we have two eyes in vision, not just one? Okay. So to see the 3D information, two eyes are there to see the 3D information. Okay. Sorry. No, do you know something is there? Na here. Do you know this one? It's not there. Oh. Rohit, take this one. Just read it out. What it says. Do you know? Read it. Read it loud. This side. Why do we have two eyes? Not one. Hmm. Yeah. So that's what Hari and Venkat told. No, it use the wider field of view, the range of vision, visibility. Hmm. Ah. What it's called? Stereopsis. Okay. Ah. Ah. Hmm. Ah. Hmm. Hmm. Yeah. There are two, especially two benefits of having two eyes. One is to field of view is wide field of view. Other is to perceive the 3D information. Yeah, to say that which person is where and how far it is. That's called stereopsis. Stereopsis. Okay. So also there is something called 360-degree cameras, right? What they do? 360-degree cameras. 360 field of view. Yeah, it will cover entire 360-degree field of view. So 180-degree field of view means they will cover only this, not back side. 360-degree field of view means it can cover entire information. Okay. What's the time? 1:35. So Hari is asking us to close a bit early, so we'll close. Huh? Tomorrow match, right? Bring scale and